This is the Honors Geometry Semester Exam Review for Unit 2, Topic 2, which is questions 53 through 63. In all of the previous videos, I've been reminding you about the formula sheet that you will get on the exam. Here it is again, and this time this topic uses this. So remember, these are the resources that you will be given on the exam. We've got our trig, sine, cosine, tangent. We've got our Pythagorean's theorem. And we've got our law of sines, law of cosines, and an area of a triangle. So these are things that you do not need to memorize for the exam. Question 53. Given right triangle ABC, use the item bank to identify the following. Items may be used more than once. So we have the leg opposite angle A. If here's angle A, this is the leg opposite, which is BC. The leg opposite angle C, that's going to be this. So we have AB. The sine ratio of angle A. So angle A is here. Sine ratio is the opposite over the hypotenuse. Remember, we have SOHCAHTOA, which tells us the sine is opposite over hypotenuse, cosine, which is the adjacent over the hypotenuse, and tangent, which is the opposite over the adjacent. So my sine ratio is going to be BC over AC. My cosine ratio of angle A is going to be my adjacent over my hypotenuse, which is going to be AB over AC. My tangent ratio of A, so here's A, that's opposite over adjacent. So we're going to have BC over AB. Then I have the sine ratio of angle C. So that's opposite over hypotenuse. So my sine ratio of C, of angle C, is AB over AC. And my cosine ratio of angle C is adjacent over hypotenuse, which is BC over AC. Next we have the tangent ratio of angle C. So that's opposite over adjacent, which means we have AB over BC. Next, we've got the angle whose sine ratio is BC over AC. So we know sine is opposite over hypotenuse, so we must be talking about angle A. Next is the angle whose tangent ratio is AB over BC. So if this is opposite over adjacent, we must be talking about angle C. And finally, the hypotenuse. This is the hypotenuse of our triangle. It is AC. So we'll write that. It's line segment AC. Question 54. Let ABC be a right triangle with right angle at C. Which statements are true? Check all that apply. Angle A and angle B are complementary. Well, we know that's true because there's 180 degrees in a triangle, so these three angles add up to 180. This is 90, so that means these two angles must add up to 90 as well. And remember, it is the right thing to do to complement someone. So complementary means right angles, 90 degrees. All right, measure of angle A. So this angle right here is going to be 90 degrees minus the measure of angle B. Well, if A and B are complementary, I would agree that that statement is also true. Okay, tangent A equals sine A over cosine A. So let's look at this carefully. We know that the tangent of A is going to be opposite over adjacent, which is BC over AC. We have the sine of A, which equals opposite, which is BC, over hypotenuse, which is AB. And we have the cosine of A, which is adjacent, AC, over hypotenuse, AB. So if I said sine of A divided by cosine of A, what I'm really saying is BC over AB divided by AC over AB. Well, when we divide fractions, we actually multiply by the reciprocal. So I'm going to be multiplying by AB over AC. These cancel out. We're left with BC over AC, which we see is the same thing for tangent A. So that is true. Next we have AB squared equals AC squared plus BC squared. We know that's true because that is Pythagorean's theorem. Next we have the sine of A. Well, the sine of A is BC over AB, opposite over hypotenuse. And we have the cosine of B, which is, B is right here, so adjacent over hypotenuse, which is BC over AB. So we know that that's true. We also know that that was a rule we studied about the relationship between sine and cosine. Next we have cosine of A equals sine of 90 degrees minus A. Well, 90 degrees minus angle A is going to be angle B. So cosine of A equals sine of B. Like we said above with sine A equals cosine B, cosine of A is going to equal the sine of B, so that must be true. And if you need to, you can show the cosine of A is AC over AB, and the sine of B is also AC over AB. Finally, if angle A is congruent to angle B, then the measure of angle A equals 45 degrees. Well, that's true because 45 plus 45 is 90, and we know A and B are complementary, so all of the statements are true. For question 55, look at the two triangles below. Sandra says that since the two triangles are congruent, then sine A must equal sine B. Is Sandra correct? Justify our answers. So Sandra is not correct. She is correct that they're congruent. So although the two triangles are congruent, we know that sine A does not equal sine B. We know that sine A is going to equal cosine B, which is how we know that it's not equal to sine B. But let's show why. So, although the two triangles are congruent, sine A does not equal sine B because the sine of A, so here is A, that's opposite over hypotenuse. So the sine of A is going to be 12 over 20. And the sine of B, so that's right here, opposite over hypotenuse, is 16 over 20. And we know that 12 over 20 does not equal 16 over 20. So Sandra is not correct. 56. Look at the figure below. We need to show that the value of cosine of S, so S is right here, is the same if I was looking at triangle SQU, so looking at this big triangle, or if I use triangle SRT. Well, cosine of S, when I use, let's start with triangle SQU, cosine of S, which is right here, is going to be my adjacent, which is going to be 12 plus 8, over my hypotenuse, which is 15 plus 10. 12 plus 8 is 20, 15 plus 10 is 25, and if I divide my numerator and my denominator by 5, I'd get 4/5. So the cosine of S is going to be 4/5. Now if I look at triangle SRT, my cosine of S is going to be my adjacent over my hypotenuse, which is 8 over 10. If I divide both numbers by 2, 8 divided by 2 is 4, 10 divided by 2 is 5. So the cosine of S equals 4/5. So now we've shown that it's going to be the same no matter which triangle we use. Next it asks, what is the value of the sine of U? Well, here's angle U. Sine of U is my opposite, so that is 12 plus 8 over my hypotenuse, which is 15 plus 10. So the sine of U is opposite, which is 12 plus 8, over my hypotenuse, which is 15 plus 10. This becomes 20 over 25, and like above, this simplifies to 4/5. So the value of sine U is 4/5. For C, is cosine of U equal to cosine of T? Why or why not? So let's start with the cosine of U. Here's angle U. Cosine is adjacent over hypotenuse. So we're going to have 15 over 15 plus 10. This is 15 over 25. And if I simplify this, divide both my numerator and denominator by 5, 15 divided by 5 is 3, 25 divided by 5 is 5. Now we got to look at cosine of T. Here's my angle T. Obviously I can't be looking at this angle because that's not part of a triangle. So I'm looking at this angle. Cosine is adjacent over hypotenuse. So it's going to equal 6 over 10. Well, if I divide 6 by 2, I get 3. If I divide 10 by 2, I get 5. Therefore, cosine U equals cosine T because they both equal 3/5. Question 57. A skateboarder has a piece of plywood that she wants to use as a ramp. The plywood is 16 feet long. So here's our plywood. She wants to put a vertical support under the ramp so that the ramp is at a 20-degree angle to the ground. This is shown in the figure below. The view is from the side of the ramp. So they want to know how high is the vertical support, and we're going to round our answer to the nearest hundredth of a foot. Well, the vertical support is my opposite of 20 degrees, and I'm given my hypotenuse, so I should use the sine. Sine of 20 degrees is going to equal the vertical support over 16 feet. Well, I'm going to multiply both sides by 16 feet. Don't worry if you're doing this without the units. And this is going to give me a vertical support that equals 16 times sine of 20 degrees feet. Well, if I multiply this out and make sure that your calculator is in degrees, we're going to get 5.47 feet. And I will say that we're going to get approximately because we have rounded it. Although I won't take off if you use an equal sign. Question 58 is a similar type of question. So Josh has a 17-foot ladder. When you get word problems that don't have diagrams, I highly recommend that you draw a picture. So Josh has a 17-foot ladder that he places against the side of a vertical wall. So the top of the ladder is 15 feet up the wall. So we know that my ladder is reaching a height of 15 feet. Safety guidelines state that the angle that the ladder makes with the horizontal can be no more than 70 degrees. So my theta can be no more than 70 degrees. Can Josh safely place the ladder against the wall? Well, we need to find out what that angle is. Since I'm given the opposite of the angle and the hypotenuse, I'm going to use sine. So the sine of theta is going to equal 15 over 17. We need to solve for theta, And we can't just divide because we're taking the sine of that angle. So the way to get rid of the sine of that angle so that we just have that angle is to do the inverse. So I'm going to take the inverse sine of sine of theta. And what I do on one side, I must do on the other. So I'm going to take the inverse sine of 15 over 17. This means I'm going to get theta equals, or I should say, theta is approximately 61.93 degrees. So can Josh safely place the ladder against the wall? Yes, he can. And you should state why. So yes, he can, because the angle is 61.93 degrees, which is less than 70 degrees. And for part B, suppose that Josh wanted the top of the ladder to be 24 feet up the wall. In order to meet the safety guidelines, what is the minimum length of ladder that Josh needs? Round your answer to the nearest hundredth of a foot. So we now want this ladder to be 24 feet up. The minimum length would be with our greatest angle, which has to be 70 degrees. So we want to know what's the minimum length of ladder. So that's going to be our unknown. Again, I've got this angle, I've got the opposite, and I'm trying to find the hypotenuse. So I'm going to use sine. So the sine of 70 degrees equals my opposite, which is 24, over my hypotenuse, which is x. I'm going to multiply both sides by x. So I have x times the sine of 70 degrees equals 24. Now to get x by itself, I'm going to divide by the sine of 70 degrees. So what I know is x equals 24 divided by the sine of 70 degrees. And when I put that in my calculator, I get x is approximately 25.54 feet. So that is the minimum length of ladder that Josh needs in order to meet the safety guidelines. Question 59. A plane takes off from a runway and climbs at an angle of elevation of 15 degrees. So we've got this runway, the plane takes off, and we have an angle of elevation of 15 degrees. After the plane has traveled 1 mile, which is 5,280 feet, so that's how far the plane has traveled, we want to know how far is the plane traveled horizontally. So how far have we gone horizontally? Well, we want to find the adjacent side. We're given the hypotenuse, so we should use cosine. So the cosine of 15 degrees is going to equal x over 5,280 feet. So I'm going to multiply both sides by 5,280. And I'm going to have x equals 5,280 times the cosine of 15 degrees. Well, when I put this in our calculator, I'm going to get approximately, and they want me to round to the nearest foot, of 5,100 feet. Now, after the plane has traveled 1 mile, so we've got the same situation, 5,280 feet, how far has the plane traveled vertically? So we still know we have a 15-degree angle of elevation, and I want to know how far is it traveled vertically. So because I'm now wanting to find the opposite, and I'm given the hypotenuse, I'm going to use the sine of 15 degrees, which is x over 5,280. So I'm going to multiply both sides by 5,280. So both sides by 5,280. And I'm going to have x equals 5,280 times the sine of 15 degrees. I'm rounding to the nearest foot, So x is going to be approximately 1,367 feet when I put it in my calculator. Question 60. A farmer wishes to make separate sections of a piece of land as shown in the figure below. All triangles are right triangles. So we know that this last triangle right here is also going to be a right triangle. So what is the value of x? All right, I can use Pythagorean's theorem for this. So a squared plus b squared equals c squared. We've got 20 squared plus 15 squared equals x squared. 20 squared is 400. 15 squared is 225. The sum of those two is 625. And then if I square root both sides, we're going to get x equals 25. So the value of x is going to be 25 meters. All right, to find y, we're given a leg in the hypotenuse, but we can still find it using Pythagorean's theorem. So a squared plus b squared equals c squared. A squared is going to be 25 squared, b squared is y squared, and c squared is 65 squared. So 25 squared is 625 plus y squared, and 65 squared is 4,225. I'm going to take away 625 on both sides. So we get y squared equals 3,600. And then if I square root both of those sides, y is going to equal 60. So the value of y is going to be 60 meters. Finally, I'm going to find the area of the trapezoid. What this really means is I need to find the area of this triangle, and this triangle, and the sum of those three areas will add up to the area of the trapezoid. So the area is going to be the area of 1 plus the area of 2 plus the area of 3. Well, let's start with 1. Area is 1/2 base times height, which is 1/2. My base is 15, my height is 20, and this is going to become 150 meters squared. So we know we're going to have 150 meters squared. The area of 2 is 1/2 base times height. So that's 1/2 times 25 times 60, which is going to give me an area of 750 meters squared. So we know we're going to be adding 750 meters squared. And then we have to find 3. 3 is a little bit more complicated because we need to find the base and the height. All we know is the hypotenuse. But it is possible for us to do this. It's just going to take quite a few steps. So I know that this angle's 90 degrees. I know that this angle's 90 degrees. But I don't know what these two angles are. If I could find one of these angles, that would help me because I could use trig to find my other two sides. Well, this is going to be impossible to find. But I can find this angle because I know that 1, 2, these three angles add up to 180, which means that this angle plus this angle adds up to 90, since this is a right angle. And I can find this angle because I know two side measurements. So let's first find that angle. And the way I'm going to do that is because I know my opposite and my adjacent, I'm going to use tangent. So the tangent of, I'll call this theta, theta 1, let's say. Tangent of theta 1 is going to equal 20 over 15. Remember, the way we find theta is we have to take the inverse. So the inverse tangent of tangent theta 1 is going to equal the inverse tangent of 20 over 15. That means theta 1 is going to equal the inverse tangent of 20 over 15, which is about 53.13 degrees. So this is approximately 53.13 degrees. That means that theta 2 is going to equal 180 degrees minus 90 degrees minus 53.13 degrees, which means that this is going to equal about 36.87 degrees. Again, if I want to be all particular, these actually should be approximately. And now we know this angle, and this is going to help us because we know the hypotenuse, so we can find our opposite using sine and our adjacent using cosine. So we have, I'll use a different color here. Let's start with this side. Let's call it W. I'm going to take the sine of theta 2, which is 36.87 degrees. So obviously this is rounded. It's not going to be exact, but it's going to be pretty close. The sine of 36.87 degrees is going to equal W over my hypotenuse, which is 60. So W is going to equal 60 times the sine of 36.87 degrees. So W is approximately 36 meters. My other side, so we can say this is approximately 36 meters. My other side is going to be cosine. So the cosine, let's call this Z. The cosine of 36.87 degrees is going to equal my adjacent, which is Z, over 60. I'm going to multiply both sides by 60, so Z is going to equal 60 times the cosine of 36.87. I'm running out of space, sorry about that. Z is going to equal approximately 48 meters. So we know Z equals 48 meters. So now all I need to do is find the area of this triangle, which is going to be, pick again a different color. Area is 1/2 base times height. So the area is going to be 1/2 times 36 times 48. So my area is going to be 864 meters squared. So I'm going to add that to this last part. And my total area when I add these together is going to be 1,764 meters squared. And that is the area of my trapezoid. Question 61. A swimmer tries to swim straight across a stream. The stream is 100 feet wide, and a current in the stream perpendicular to his intended path caused him to land 20 feet downstream from his intended landing point. So the question is, how far did he swim? Give your answer to the nearest tenth of a foot. So what we want to know is, how far was this actual path? How far did he swim? So we have this unknown angle. We have the length that he should have swam, how far he landed downstream. We know that this is a right triangle, so we can use Pythagorean's theorem to solve this problem. A squared plus b squared equals c squared. We have 100 squared plus 20 squared equals c squared. 100 squared is 10,000, 20 squared is 400, and the sum of those two together is 10,400. To get c by itself, I'm going to square root both sides. I'm not going to use the negative because we can't have negative distance. So c is going to be approximately 102.0 feet. Now, why did I get 102.0? Well, the square root of 10,400 is actually 101.9803,903. We were asked to round to the nearest tenth. That means I need one spot after the decimal point, which means I look to the next number after that. Well, 8 rounds up, so 9 is going to round to the next spot, which is 10 or 0. So we're going to have 102. But because it asks for us to round to the nearest tenth, we need to have that 10th spot. So it's going to be approximately 102.0 feet. For part B, we're asked at what angle was his actual path to the intended path. So give your answer to the nearest tenth of a degree. So we need to find this angle. We're given, for certain, without rounding, which is our actual path, we're given the opposite and the adjacent. So the best ratio we should use is tangent. So the tangent of theta is going to be my opposite, which is 20 feet, over my adjacent, which is 100 feet. Well, remember, to get theta by itself, we have to take the inverse. So the inverse tangent of theta is going to be theta. And what I do on one side, I have to do on the other. So I'm going to take the inverse tangent of 20 over 100. Well, the inverse tangent of tangent theta is theta, and the inverse tangent of 20 over 100 is approximately 11.3 degrees. Question 62. Kevin purchased 2 farms. Currently, the 2 farms are connected by 2 roads. Kevin wants to construct a new road connecting the 2 farms directly. So he wants to construct this road. And here's our situation. So this is 14 miles, this is 23 miles, and we know this included angle is 68 degrees. What will be the length of the new road? All right, and your answer should be correct to the nearest hundredth of a mile. Well, what we know is we have an angle. We want to find the side opposite that angle, and we're given 2 sides. Since it's not a right triangle, we can't use our trig the way that we know it, but what we can use is the law of cosines. And this is on your formula sheet. So law of cosine says c squared equals a squared plus b squared minus 2ab cosine c. So we know that it doesn't matter what side's A, what side's B. We can call this A, we can call this B, but this is going to be C because that's what we're trying to solve for. So this is our angle C. So c squared is going to equal 14 squared plus 23 squared minus 2 times 14 times 23 times the cosine of 68 degrees. I highly recommend that you do this in parts. So 14 squared is 196, 23 squared is 529. Negative 2 times 14 times 23 is negative 644, and that's going to be times the cosine of 68 degrees. So c squared is going to be 196 plus 529, which is 725, minus 644 cosine of 68 degrees. So c squared is going to be approximately 725 minus 241.247, because that's what 644 cosine of 68 degrees is. But when I put this in my calculator, c squared, and I do 725 minus that number, I'm going to use the exact answer in my calculator. Even though I've rounded it here on the sheet, use your exact answer, and you'll get about 483.75. Then I'm going to square root both sides. But again, I'm going to square root my exact answer using the answer function on my calculator, and C is going to be approximately 21.99 miles, because they did ask us to round it to the nearest hundredth of a mile. Part B says the federal government is planning on marking the area between the two existing roads and the new road into a national park. So we're going to take this area and make it into a national park. What is the area of the park? Your answer should be correct to the nearest hundredth of a square mile. Well, as given on our formula sheet, the area of a triangle, when we don't know the base and the height, is going to be equal to 1/2 times AB sine of C. So we're going to use the same letters. You know, this is A, this is our B, and we're taking the sine of C. So this is going to be 1/2 times 14 times 23 times the sine of 68 degrees. Well, 1/2 times 14 times 23 is 161 times the sine of 68 degrees. And when we put that in our calculator, we're going to get our area to be approximately 149.28 square miles, or miles squared. Don't forget your units, and don't forget to square them because area is always units squared. And for our last question, 63, a roof is being constructed on a building and slopes differently on the two sides as shown in the figure below. What is the length of the roof represented by BC? So this is our unknown. Remember that across from angles, we can say that like this is side A, this is side B because it's across from angle B, and this is side C because it's across from angle C. Our answer should be correct to the nearest hundredth of a foot. Since we have two angles, first of all, we can find the third angle, angle B. So the measure of angle B, there's 180 degrees in a triangle, minus 79 degrees, minus 43 degrees. So the measure of angle B is going to be 58 degrees. Since we know all of our angles and we just want to find one of our missing sides, we're going to use the law of sines, which is also given on the formula sheet. Law of sines is we can take the sine of an angle over its corresponding side, and that will be equal to the sine of another angle over its corresponding side. Since I know side B and angle B, I'm going to use that. So I'm going to use, sine of B over side B. And since I'm trying to find BC, which is across from A, I'm going to use the sine of angle A over side A. Well, sine of B is sine of 58 degrees over side B, which is 20 feet. And sine of A is sine of 79 degrees, and I want to find side A. So I'm going to cross multiply, and I'm going to get A times the sine of 58 degrees equals 20 times the sine of 79 degrees. Since I want A by itself, I'm going to divide both sides by the sine of 58 degrees. And I'm going to get A equals 20 times the sine of 79 degrees divided by the sine of 58 degrees. I'm going to put that in my calculator, and A is going to be approximately 23.15 feet. And that is the end of our Honors Geometry semester exam review.